Awesome. Awesome. Well, everybody joining us today, you are in the right place. Hopefully, this is the equipping students with a best-in-class additive manufacturing platform webinar. So again, thank you for joining us today. We will plan to have this all wrapped up at the end of the hour. I'm super excited for today's contents. We have a few of us joining. My name is Jason Rose. I'm a channel manager here at Markforged. And then Ross and Dave, please introduce yourself really quick.
Hey everyone, my name is Ross Adams and I work on the application engineering team at Markforged.
Hi everyone, I'm Dave Follett. I work at UMass Amherst and I run our AdFab lab, which I'll tell you more about, that does all kinds of additive manufacturing.
Awesome, awesome. Thanks guys for joining today. So again, quick agenda for our webinar today. This is all going to be about a focus on the educational market, specifically for institutions, professors, students, all of the above. So as we start today, I will get into a little bit about why Markforged has a specific focus on education and what's driving really a lot of this content and some of the conversations we're having with customers. Again, educational customers, students, and then also on the industrial side. Then we will move into why should educational institutions focus on additive? Again, I know a lot of you are listening and paying attention to a lot of what's happening on the manufacturing side of the market, and that's driving some of your decisions. So we will get into that. I will then turn it over to Dave. He's gladly sharing some time with us this afternoon to talk about his journey building an additive program at UMass Amherst. And then we will go to a former UMass student who is now a Markforged employee, Ross Adams, that will talk about life after graduation and really what he learned in school and how that did help prepare him for life after graduating from school. So first, just really quick summary about Markforged. We've been around since 2013. That's when we started developing our first technology platform based around composites. And then obviously since then, we've moved into additional materials with metals, with building out a software platform. We are headquartered in the Boston area throughout multiple facilities. We do all the design and everything is manufactured for our platform. It is all manufactured within the States. So again, that's across hardware, materials, and software is all done here in the States. Really quick, a key notes about our organization. We are still a technically led organization. About 45% of our employees are in engineering or in technical roles, helping support our customers. We do have roughly about 37 patents across the entire platform. And a few quick notes. I take a lot of pride in this as a longtime Markforged employee. 2018, we were listed on Forbes's next billion-dollar startup list, which was super cool, knowing where startups usually start from, which is zero. Then also from Deloitte, who is a very famous consulting company out there in the market. They put us on their Fast 500 as the fastest growing 3D printing company in the market. So again, a lot of personal pride in talking about this slide here. I will kind of turn over to that chart that you see on the bottom hand corner of your screen. Again, really proud to say that since 2013, we are currently in 2019 holding about 13% market share for industrial printers, which I think speaks a lot to how our customers, how our educational institutions are using our platform, because a lot of what we've done is coming from really just word of mouth from our customers, from educational institutions. So let's move into this a little bit. Again, why does Markforged have some focus on this? Just like a lot of you, whether you're in a leadership role at an institution, a professor, or a student, a lot of what you're doing is you're listening to what the market might need. We're doing the exact same thing here at Markforged. So we do have the benefit of having a pretty nice sized customer base, roughly about 15,000 customers. Again, we are one of the fastest growing in additive right now. But what this provides us is a lot of really strong feedback from our manufacturing customer base coming back to Mark Forge saying, here's some of the things we'd like to see, both within the technical platform, but also the way the way we do business. And kind of at the intersection of this is the other end of the spectrum of the institutions that are preparing students for life beyond graduation to go and work at possibly one of those 15,000 customers that's already using our platform. So again, a lot of what Mark Forge is doing is, and you see this within our mission statement, talking about trying to reinvent manufacturing today so you can build anything you imagine tomorrow. So again, if you kind of look at this holistically, we're receiving feedback from our educational customer base. We're also receiving a lot of feedback from our manufacturing customer base. And I'd kind of like to take our marketing mission statement, and I'd like to change that for today's conversation. Let's reinvent education today so students can build anything they imagine tomorrow once they leave your institution and go into the field and start working at some of these manufacturing customers. So where are we at today? Let's kind of do a level set collectively. So current states in education. This is, as somebody from the Midwest, I take a lot of pride in the Midwest educational institutions. I just pulled two from online, Purdue University and also North Dakota State University. And you'll see a lot of correlations between these universities and their goals as an institution to a lot of what you're seeing, whether it's at your school that you're attending or the institution you're working at. And what these two correlations are really two main focus points. Is the institution is focused on enrollment of the students, but then they're also focused on preparing students for life beyond graduation as they move into industry. So you'll see this across a lot of institutions' websites. Again, they have metrics all over their website talking about enrollment numbers and some of the growth, but then also some of the graduation rates on the back end. One thing I will like to point out within some of these images is you'll see both with Purdue University, they have growing enrollments, but they also have growing enrollments specifically for your STEM sections of their organization. And you'll see that same thing with NDSU, where NDSU actually has a decreasing total enrollment, but increasing in engineering enrollment within their school, which again is very enthusiastic for a lot of us that come from the manufacturing industry, just showing that a lot of the manufacturing jobs, they're there, and we're looking to prepare students for what's next in their career, potentially at those manufacturers. So let's start taking a look at what the future state in manufacturing is saying, because that's also playing into a lot of the decisions that universities and students are making today. And this is, again, from Deloitte. They're one of the largest consulting agencies that comes to market with a lot of reports from their customers. And this was something from at the end of 2018, where they're talking about the jobs being here in manufacturing, but they're also highlighting the skills gap that a lot of us are aware of in the current state, but more importantly, how they view this skills gap growing in the future and the things we need to do today within the institutions to help prepare for this potential gap in the future. And again, the potential gap growing in the future as we go through time. So why additive manufacturing? Why additive in manufacturing, excuse me. So a lot of us have heard about the fourth industrial revolution and how it's here, it's coming, it's going to change the way we do business. The interesting thing about this industrial revolution is it's going to impact every industry that our students might be going into. So it's not just specific towards automotive, it's going to be across all industries as a whole. So here's a few stats about the additive manufacturing and how it might play into this fourth industrial revolution. So the fourth industrial revolution does include IoT, it includes robots, but additive is one of the major sections of what they believe this revolution is going to be when we look back on it once we're through. So again, on the left-hand side, you're looking at growth over the last 10 years or so within end-used applications in additive, basically showing that there's starting to become this exponential growth in the way that companies are applying additive to their business, specifically for end-use applications. So that's going to be a lot of your metals, a lot of your composites, some of your plastics. And then on the right-hand side, you'll see another study from Smart Tech that's talking about the growth specifically of composites, which I think is very interesting because, again, that's really one of the major areas that Markforged plays in terms of providing technology to their customers. So another tidbit from the fourth industrial revolution, this is coming from McKinsey and Company. Again, another large consulting company looking at the industry as a whole. They're talking about, again, comparing the fourth industrial revolution to some of the previous revolutions. And what they're looking at is, as you'll see, 50% replacement of a lot of the equipment we're using in manufacturing, they think is going to be either replaced or repurposed in a different fashion, which is very interesting to us because I think a lot of us have seen over the last 20 years since the last industrial revolution is, again, we walk into facilities and we see CNCs, we see a lot of this technology, and they're basically saying we expect a change. They just don't necessarily know when that change is going to come, what the impact is actually going to be of that. One impact that they do foresee is that normally as you go through these industrial revolutions, you'll see a changeover from who was a previous industry leader to who a new industry leader is. And this is something from InnoSights, who's talking about how they're seeing this change from an industry leader to no longer being an industry leader. They're seeing this time frame really start to speed up within the last revolution and within the current one. So where to start? That's one of the top questions that educational institutions ask us when they get involved within this evaluation. So really, it's a quote that I love to bring up and quote in front of customers, because I think it really brings us home to what we're trying to accomplish here is, again, from Deloitte, successfully implementing and scaling additive manufacturing technology to an industrial level, or even to determine whether it's economically justifiable, often requires organizations to consider factors beyond the additive manufacturing machinery itself. This is very important as you'll see as we get into, and this is one thing that we work with our educational customers, but also with our manufacturing customers, is how do you break down a quote like that into pieces where you can say, okay, we're going to adopt additive and we're going to build a specific program around it, and how do we ensure success of that program? We like to follow basically 3 different verticals. It's across people, process, and technology. So let's kind of dissect this a little bit. Let's talk about the people. Every university institution, whether you're a 2-year school or a 4-year school, has a overarching mission statement from the university. So the first thing is make sure your team is aligned with the mission statement on what you're trying to accomplish and what the major goals of the institution are. Then you move to the strategic partnerships. Who are you going to work with as you're going to solve some of these initiatives that you're looking to put in place? And then the last piece that a lot of educational institutions come to us asking is, what is that feedback from the market? So in this example, what is the feedback from manufacturing, and specifically what is manufacturing looking for? Because that helps drive some of the plans we have on how we educate our students. So let's dig into a few examples. Again, just a couple customers of ours and some of the things that they've lived through. And here are a couple quotes from some of our case studies of somebody like Purdue. David McMillan, he's the assistant director of the Bechtel Center, who's housing a lot of their additive equipment and their additive program today. And he's quoted saying, allowing students to make mistakes and learn from them in a controlled environment, which better prepares them for the workforce on the back end. So again, it's giving students a lot of access to what you might call R&D and understanding what additive is, and specifically how you apply it to applications on the back end that they might run into once they graduate. And again, Oklahoma State University, another customer of ours, adopted technology across our metal platform and our composite platform. And one of the cool things I think they say is that the Endeavor program that they have partnered with several industry leaders in energy and aerospace to help fund the center, which has brought a lot of buzz to the facility. So a lot of organizations come to us saying, Jason, we want to buy an additive program. First things first, we need to figure out how we get there and how we start. And that usually starts with understanding grants within that specific state, possibly federal grants. But like what Oklahoma State is showing is they've actually partnered with a lot of their industry partners to help grow these programs. And there's much more alignment between what the institution is doing and then also what manufacturing is really desiring on the back end. So the next pillar of these three pillars is the process. So how do you build a blueprint for program transformation? How do you educate and enable your students? And then also, how do you really accelerate the additive adoption within your institution or within your specific department or your specific program? So let's kind of dissect this a little bit. I'll summarize this with a lot of what we already know within the educational side of things. So again, it's a focus on education and enablement. This is something that everyone on this call has likely lived within, is you're looking at the importance of training and making people successful on the back end. If you don't have structured programs, you're likely going to see a drop in potentially students being able to get future certifications or students being able to get really those desired jobs that they want post-graduation. So a few things that Markforged is doing to help with this. This was initially developed from feedback from our manufacturing clientele. We are now bringing this to the educational market. It's a program called Markforged University. It's a training enablement and certification program centered around the Markforged ecosystem and what really our customers are asking for on the manufacturing side. So again, this can help with skill acquisition, technical adoption, and really help you with return on investment for the investments you make in the technology. So again, a little bit more on Markforged, Additive Manufacturing University, again, allowing you to really de-risk your investment in the technology, upskill your workforce, and really enable your students to understand applications, where to look, potentially the business case behind additive within a manufacturing environment. And again, one thing we will be delivering, you'll see from us this summer, is a few different delivery models for this, just because I know every education institution is not run the exact same way. Some professors might want to do a lot of curriculum that is lab-based. We also have other professors that might want to do a little web-based curriculum mixed in with some other lab-based. But on the back end of this, we will give institutions the ability to essentially certify any of their students to become a Markforged certified additive expert. This is the same certification that somebody on the manufacturing side will go through in the testing that they will take. So again, really helping prepare these students for life beyond school. So the last piece, technology. A next generation technology platform. Nobody wants to buy something that's then becomes obsolete or does not have value in the manufacturing space. Everybody wants something easy to use, proven, reliable, and repeatable. And then also a platform used by local industry, because a lot of the students coming out of your programs are likely going to local manufacturing customers. So again, really quick on our platform, that's not the purpose of the call, but for anybody new to Markforged, just want to quickly hit on it. Again, we do full stack development of our platform across the hardware, the software, and industrial materials with composites, metals, and plastics. And again, one really cool thing that's a lot of people don't necessarily know until they get involved with our platform is the ability to mix a lot of these technologies, which essentially just proves that there's much more need for a lot of this curriculum, because you can take a composite part, mix it with a printed metal part, and come up with a solution that really could not be manufactured previously with previous techniques. So again, getting the ease of use. Again, full platform is it's full stack development across software, hardware, and materials. I'd recommend, we do have free trials of our software. We can also set up demonstrations to help you understand what the workflow might look like, both for professors teaching our content, but also from students who are going to be using the software and eventually using the hardware. And again, one really cool thing I think we do is a lot of our development is driven specifically from customers. We put this to use internally across our fleet that we're using to make a lot of our benchmark parts and our sample parts. We make roughly 15,000 parts a month across one operator within our facility. So it just talks to the power about our ecosystem. And again, last piece here is just talking about strategic partnerships and what's coming in the future. So you'll see partnerships with us, with actually a customer turned investor who is now turning into a technical partner of ours. Someone like Siemens. You also see this grow with organizations like MSC getting into potentially FEA integrations with some of our parts that you can then use to just better understand what part you're getting off the machine on the back end. So again, is a summary, before I'll turn it over to Dave, is again, some of the things that we're here to help you with across people. Again, feedback from our manufacturing clientele of roughly 15,000 manufacturing customers, roughly about 1,000 educational customers. We do have an ecosystem help make you successful across our 170 resellers across the globe. We then transition that into a process you can follow to help you really build a more in synced program with certifications on the back end for students. And then obviously I talked about some of the technology and really where we are today and where we're going in the future. So with this transition, I'd like to turn it over to Dave, who's going to talk a little bit about his program and what they built at UMass Amherst. Dave, welcome.
Great. Thank you, Jason. So thank you, Jason and Ross, and actually all of Mark Forged for the invitation. It's really fun to be here on the webinar, and exciting to talk about getting more additive into the university setting, kind of like we have. The more I do this and the more I work with students, the more I wish that I had this when I was a mechanical engineering student. Really not that long ago, but it's really changed a lot in the last decade, 15 years. So I hope that I can do that for students these days as well. So like I said, my background is mechanical engineering. Before working at UMass, I was all industry before getting into education. I worked at Carbon 3D, another 3D printing manufacturer. So a little bit of experience there, but really I think 3D printing is new to a lot of people. So it's a great place to learn. If you have any additional questions sort of after this webinar, feel free to reach out to me directly. I think you can find me online at UMass or LinkedIn or basically just Google. So feel free to reach out if you have any other questions. So next slide. So we are housed in the life science labs at UMass Amherst. If you're not from Massachusetts, Amherst is not that close to Boston. It's about 2 hours west, but it is a beautiful campus. It doesn't look like that today. It's cloudy and rainy and there are no people. Behind me also, it's cloudy and rainy and no people, but it still is a beautiful campus. Our facility, called the Advanced Digital Design and Fabrication Core Facility, was a $3 million piece of about $100 million grant to build this building from the Massachusetts Life Science Council. So state funded. Our lab's actually on the back side of the building, one or two of the rooms in there, but it is a nice new giant facility, which is great. It is run by me, who is actually not faculty, so I am staff there. That's somewhat on purpose so that I can focus on running the lab and not be focused on research or teaching actually at all, just sort of on the side. With me, I have quite a bit of student staff, both graduate and undergraduate, and I'll say there's a lot of student interest in working at the lab and learning about additive, which has been great. We're not set up with specific industry partners per se. We did purchase all of our printers on our own. We have quite a few industry customers. Almost 3/4 of our revenue is from industrial customers, but we're not set up in the sense that somebody donated the printers and we kind of work with them. We work for everyone and go from there. So next slide. So a quick view inside of our facility. This is just one of the lab spaces. It's great to be on the UMass campus. There are a lot of benefits being in an academic setting. You get, in our case, very nice facilities. You have, electrical, you have ventilation, you have all these things you need. Coming from industry, getting rid of hazardous waste is a challenge in industry and costs money. On campus, environmental health and safety really wants to make you safe and make sure it's treated properly and doesn't even charge you, which is great. So we have a lot of nice features as part of being part of the university. And we have a big variety of printers. We have 5 different printing technologies. We have a laser cutter, we have an Instron dynamic tester, we have a coordinate measurement machine. So it was really designed to be a full-on, not just 3D printing, but digital design and additive fabrication. So next slide. So I like to summarize kind of what we do in kind of 3 pillars. So the first one may be kind of the most obvious, designing and printing great parts. So I break it into the materials that we use. So we do print in powdered metal, mostly stainless steels. We print in powdered nylon in an SLS process doing nylon 12. We have Stratasys printers that do an object multi-material, and we also have Markforged that do both composite fiber infused, so like the onyx, and then fiber reinforced, like the continuous carbon fiber mode. To talk about the Markforged just briefly, what I like about it, we have the Onyx 1 and the Mark 2. I would say it's been interesting coming from a 3D printer maker and then using 5 different manufacturers of 3D printers, 5 different types of 3D printers. The user interfaces are all different and all require some kind of training. Eiger is my favorite by far and the easiest to use. I'm not just saying that, it is. It's nice that it handles lots of users with ease, and it warms up and is ready to print like immediately. So because of that, a lot of these other printers are pretty complicated to use, and I don't let students use them on their own without quite a bit of training. But we let students run the Markforged themselves, and they love it because they can prototype a part like today in hours. And if they want to work at 2 in the morning and prototype something then, like, I don't have to get up, I don't have to help them, they can just do it. So we can give them access to that room that has it, and then they can use it, which has worked out really well. So next slide, please. So the other, second pillar of kind of what AdFab does is really research in additive manufacturing. So that falls into really 2 basic categories. One is really in the metal space. We do metallurgy research. So it's what would a new alloy look like for 3D printing? You have your stainless steel 15.5 and 17.4. Those weren't optimized for additive because additive wasn't around when they were invented. So what if we look at different alloys? So we have some faculty who are printing in all different types of powders and then building dog bones and then testing those in all different ways. So that's one category. The second area is really around geometries. So a lot of geometries that you couldn't make before using other techniques, and then interesting ways of applying that. So a lot of people look at lattices for, all different applications. In the picture here, we're looking at a novel lattice in metal, and metal is challenging to print in. So the value add that we provide isn't just the printer, but how do you print something complicated like that using this technology? So it's still a science and an art to figure out how do I orient this, where is it supported or not, what are the tricks to getting this to work. Next slide, please. And the third part is teaching. So I support, the undergraduate and graduate classes on 3D printing. Okay, I'm on. So my son is here, so he's gonna go. Alex, it's time to go there. So sorry about that. Interesting timing. I had this whole time blocked out, and he picks the 1 10-minute piece. But anyway, so we're teaching additive manufacturing, both the undergrads and grads on campus, but then we do workshops for people in industry. So mostly do hands-on, because that's kind of what I find interesting, is learning how to use the printer. And we do, and I think it helps a lot as a designer to actually have used a printing process from start to finish to really understand how to design a part for that process. And for the hands-on part of these courses, I actually have students do a lot of the teaching because they use the printers a lot and are as skilled as I am or better. And that's resulted in a lot of good connections between students and industry, and even resulted in a couple of the internships that some of those students have even this summer. So next slide, please. So I want to talk about a couple of the projects that we're working on, at least in the last couple months, specifically during COVID, I guess, because that's been what's going on the last couple months, and kind of how our lab works with those. So one of the recent projects was working with the open source respirator project. So that is a local group to more or less Massachusetts, developing a respirator that can be mass produced and then reused with reusable filter media. So they came to us because they needed to prototype their mold cavities before they went and had a mold made. They needed head and face models, and then they had prototype parts. This was great for us. The sort of disposable PPE printing didn't fit in exactly with the type of printers we have. So this was a good fit for the tools that we have, and it was a local group doing that, and we've worked with them before, so we were able to supply some very rapid turnaround parts so they could really iterate on this quickly and get this out there. I think the other point with a project like this is you might ask how students get involved. And students are involved kind of from start to finish. This one, they weren't involved in the design piece per se, it was coming from outside. But students actually do all the operation of the printers as staff. And when the printers don't work, they have to troubleshoot the problem and figure it out. Work together, but it's a process of understanding how it works, how to fix it. And then I like to have them deliver it to the customer and meet the customer also as an opportunity to meet people in industry and make good connections. So I think it's been great. Where do the students come from? I've had almost all of them come on their own. They are quite interested in additive and sort of seek me out. I do some guest lectures and courses and help out with other courses. I also have a couple summer interns a year, but really there is significant motivation among the students, and the best ones will come and find me, which has been really great. So 2 of them are actually at Markforged now. One of them is running a metal printer at Lytron in Massachusetts, and there's one with a different metal printing internship this year. So I think it's really kind of shown that these kind of skills get people right into working in additive, which is really great. So next slide, please. So I'll move a little bit more quickly through these. This is another project that I worked on actually at home during the stay-at-home order. So when the stay-at-home order was issued on a Friday afternoon for UMass, I had a feeling it would be longer than 2 weeks, so I grabbed whatever printers I could and put them in my car and took them home. So what I took was a Markforged Onyx 1 and a MakerBot, and both have turned out to be very useful. And I want to talk a little bit about the pros and cons of each and kind of why you want different printers. So actually, if you go to the next slide, this is a project to do, we don't need to get into the details of the project, but essentially it's creating oscillating motion that can be sensed by radar. So there's a professor in computer science developing this. So these are non-electronic sensors, but we need to prototype a bunch of these different tags, they're called. So you go to the next slide. And what was great is that I could do all this at home. So I had both these printers running, and was able to compare them as well. So these are 2 parts, one printed Onyx, one printed PLA on a MakerBot. I can highlight some differences in print quality, particularly around the fine features. I will say I'm not an expert on PLA and the MakerBot. I think with tuning, it could be better, certainly. I'm not trying to say it's a bad printer or anything. I think it's a different price point, a different market. But depending on what you want, you'll get something different. So if you go to the next slide, there's another kind of backside of these parts. You can see another sort of difference in the finish. But what we did find is that I was trying to create springs or hair springs like this. And while the Markforged Onyx is an excellent material, like nylon is great, it's very durable and tough, and I can snap parts together, it wasn't springy enough to make a spring. It was not rigid enough. So it turns out the PLA worked out better as a spring. The Onyx material worked out better for all the other pieces. And if you go to the next slide, you can see the 2 things that kind of came together there. So it was nice to be able to build something that took advantage of both. I would play the video, but it's Zoom and probably won't work. So I think the takeaway for me though was that I see even my son, who you may have met here just briefly, who's in kindergarten, they start to use 3D printing in elementary school, and kids are being exposed to it very early, which I think is great. But a lot of that is with the sort of MakerBot style consumer grade printer. And I think that's great to get started thinking about additive manufacturing. But I hope that I can help share more of the industrial level manufacturing of additive with students so that they know how they would apply it at work. More and more companies are using additive for final products or short run production or things like that. And I think it's important that people know that it's not just different colors and printing your toys and stuff, and sometimes not very high quality. But I like to expose students to printers that produce really high quality parts and help them learn how to design for that and take advantage of that. So one of those students is Ross Adams, who I met at UMass and worked with me quite a bit. So I'll turn it over to him to tell you about his experience a little bit.
Thanks a lot, Dave. It's excellent stuff. I certainly, gained a lot from working in your lab, and UMass is very lucky to have that type of resource. So what I'm here to talk about today is kind of my experience, entering the workforce, graduating from UMass Amherst, and some of the skill sets that I nurtured back when I was an undergrad, and how they're still applying today and, paying dividends. This is kind of just like a rough picture of like my journey into the Mark Forge 3D printing OEM, and this is what we'll get into today. So if we go to the next slide, we'll start the journey at UMass Amherst. This is a class photo taken during our senior design projects, and if you took this photo when we were freshmen and sophomore, there'd probably be roughly twice as many students. So it's a very competitive field, and it's challenging, but those who persevere and work through it, speak personally that the reason why I was interested in 3D, well, not 3D printing, but engineering, was because the job market, you could really work at some cool companies and do some really amazing things. So it wasn't just the technical expertise that drove me to this career, but also just an interest in the skill set that you gain from it and what you can do with applying that. So, going back to college, freshman, sophomore year was mostly learning out of textbooks and getting familiar with the fundamental principles of engineering. But where it started getting interesting was junior, senior year, where we started to apply those principles and work on projects. Usually those projects would be in a group, and they would kick off the same way typically. Everyone would go around in a circle and say, these are my strengths and these are my weaknesses. And then you try to delegate the responsibilities of the project based off of everyone's strengths and weaknesses. For me, it was usually the same. My strengths, I was, well-versed in CAD design. I was familiar with SolidWorks. We were lucky enough to have that available when I was in high school. So I went into college with the foundational knowledge of design. But where my weaknesses was in the making of things, manufacturing pretty much. I wasn't comfortable hopping on a Bridgeport machine or a CNC and milling out aluminum and steel and drilling holes. I wasn't comfortable. I wasn't available enough to make mistakes and learn. So for that reason, I was, really just constrained to the design side of things. And that was kind of a bummer for me because I had this ability to reflect these ideas I had in my head into the computer, but no way to actually make them. So one day I was walking through the engineering lab's basement and noticed this closet that had a 3D printer in it. So I was like, oh, that's kind of cool. Let me go poke my head in there and see what that's about. And I asked, hey, can I print a part on this machine? Someone inside that room said, yeah, you can. There's a cost structure to print parts. Basically, you have to pay for the machine time and you have to pay for the material cost. And they said, well, if you join the club, you don't have to pay for the machine time. It's just the material cost. And me being a cheap 21-year-old college student was very gracious to join the club and save $1 or $2 per print just to, enable me more to print things. And, I was really glad that I ended up joining because it ended up, having me more invested in learning about 3D printing, and the lower cost point certainly made it so I could print more stuff. And what I found is that I was able to print things, but also it was much more flexible than the traditional manufacturing to, try new things out. What I was able to do is fail, fail quickly, but then iterate and improve my designs. What I didn't realize at the time was I was developing this like intuitive sense for design for additive manufacturing, which at the time I didn't realize was a highly, highly sought out after skill and is incredibly rare. And speaking today, the biggest challenge for 3D printing is really finding the skill set in the workforce of people who know how to design for these processes and really take advantage of the benefits of it. So, I joined this club and was 3D printing things, and then enrollment came around for the next semester, and I noticed there was an elective called MIE 373, Intro to Additive Manufacturing. And I wanted to learn more about 3D printing. To this point, I was just familiar with the hobbyist printers, and I figured there was a more industrial side to this, so I signed up for the class. Most of it was taught out of a textbook, but probably the most beneficial thing that came out of that class was we took a tour of the AdFab lab, which is Dave's lab that he just spoke about. And this was really exciting for me. And after we took this tour, I hung around and introduced myself personally to Dave and said, offered myself as a volunteer at the lab, saying, I'm familiar with SolidWorks, and if you ever need some help with design, I'd be happy to volunteer some time. And of course, Dave graciously accepted my initiative to work with him. And after a few weeks of designing parts that he would print on his printer, I realized that this design for additive skill actually is highly valuable, and there became opportunities to kind of freelance design work and produce parts that Dave would print for local businesses or researchers. And that got me really excited about 3D printing. It kind of introduced me to this giant wave that's coming in this industry of industrial applications for 3D printing. But it wasn't just me doing additive. If we move on to the next slide, I'd like to share some other examples of other projects that were going on. So this is the super mileage vehicle. It's a nationwide competition that takes place with undergrad engineering colleges. Basically, they build this car, and it runs off of a tank of water, and the goal is to make it drive as far as it can. So lightweighting is very important. But also, another side of thing is time to market. These students don't have much time to work on these projects. They have other classes in the way. They have homework and other projects as well. The picture in the top left is a steering wheel that was used on the car the semester previous. And as you can see, it's pretty clunky. It's made out of a block of aluminum, welded with some steel rods at the end and some nuts and bolts. It's really not optimized at all and doesn't really excite me. One of the students who was working on this project, and he's actually one of the students that now works at Mark Forge with me. He's a good friend of mine, Tom Randolph. He took the responsibility during this project to redesign the steering wheel, but knowing that he'd be 3D printing the part end use. And that's reflected in the picture beneath, where you can see these organic shapes with these cavities in it that really make it much lighter of a steering wheel. But not only that, it's an end-use part that isn't just taking advantage of 3D printing, but it's rethinking the way that students can do these projects. Because the ones who can design and make their own parts are able to fail faster, able to iterate and improve those designs, and are overall much more effective. Just because things are made out of aluminum doesn't mean that they need to be made out of aluminum. And as students begin to realize that, you'll find that with projects such as the super mileage vehicle or even the senior design projects, you can really have a quicker time to market with your projects and kind of be more competitive in these engineering curriculums. Now that's what was going on at UMass, but what kind of drove me to postgraduate. I felt like I kind of missed out on the 3D printing wave. If you search the web, there's all sorts of things going on with it, and I thought that I was just kind of behind the game, too late to join. So I got my foundation working at a large aerospace and defense company. If we move on to the next slide. So yeah, I wanted to develop a foundation of engineering skill sets. So I decided to work at a large company where I'd have exposure to senior manufacturing engineers and senior tool designers. I was able to land a job as an associate tool designer, and was really excited to enter the workforce. I wanted to soak in as much knowledge as I can from these highly knowledgeable engineers. But when I got there, the adoption of 3D printing was really slow. There was a couple of misplaced applications where the 3D printed parts failed, and it really drove, their progression in the backwards direction. At the time, I didn't quite realize, but I was positioned very well to make an impact at this company because tooling is really where the explosion of applications are occurring for 3D printing today. This is jigs and fixtures. And there's a tool for just about every step in the fabrication of a helicopter. And even, if you can just print 10% of those tools, there's huge value to be realized by bringing that in-house and, reducing costs through additive manufacturing. So, soon after, I was learning a lot from these engineers, but also I was educating them on some of the stuff that I had learned during college about 3D printing. The stuff from Dave's ad fab lab and the different types of machines out there, and also the design side of things. And some of those failed applications that they had early on were just due to poor design practices that could be reflected differently, and then the tools actually perform significantly better. So soon after, a few months, it wasn't just me learning from these guys who have been working at the company for 20, 30, and even 40 years, but they had something to learn from me because I brought in a fresh new perspective and a keen sense of how to take advantage of these advanced technologies. So by no means am I taking any credit for building these type of helicopters and being, a sole responsibility. But I mean, I do take pride in the fact that, it was really cool to walk down the final assembly line as a 22-year-old and see my 3D printed tools being used on the manufacturing floor. So yeah, let's move on to the next slide and let's talk about what brought me to Markforged, because, I really enjoy this job. Like I said, I took great pride in the work I was doing, but there was something that I wanted to, transition to and with 3D printing, because, I realized that perhaps I wasn't too late. And Markforged really caught my interest because they had some unique value props that me working inside an industrial manufacturing facility realized that this technology was different. The first thing is the carbon fiber reinforcement parts. And with most of the applications in 3D printing, the limiting factor was the strength of plastic. Most people thought that tools can't be made out of plastic, but to a certain extent, that's true because tools need to be durable. But when you talk about composites and continuous carbon fiber, it's a whole different vernacular that companies, especially in aerospace, are very receptive of. And when I first felt one of these parts and felt the strength, I knew that this was something that was going to change and progress the industry. The next thing was their metal printer that Markforged offers. Back when I was working in the ad fab lab, I was super excited about the metal 3D printing. But I also recognized that with these powder-based machines, there's a lot of limitations and barriers of entry that prevent companies from really being able to adopt that technology. Aside just from the cost of capital equipment, it also just has powders, so you have to have hazmat suits and respirators and all these different things that the metal system that Markforged offers doesn't include. So it's a much easier technology to adopt, and then you can actually start printing parts in metal without all those barriers. And then finally, the last thing that brought me to Markforged was that I wanted to really be part of this industry. And what I realized is that I didn't want to just do it for a single company. I wanted to be working where I could be driving the expansion of 3D printing for the entire global manufacturing industry. And that's really what's so cool about my job at Markforged is that as an application engineer, I'm not just working within a single company. I'm working with all companies. So people will ask me, who's 3D printing? And my answer for them is anyone who makes anything is looking at 3D printing because it has the potential to, improve your business, not just to reduce costs, but secondary benefits with supply chain and, bringing manufacturing in-house. There's all sorts of new advantages to it. And it's really going to shift the way that people make parts in manufacturing. So some days I'm talking to aerospace companies. Some days it's automotive. A lot of the times it's education. It's consumer products, eyewear, footwear, refrigerator companies. And sometimes it's all these companies within the same day. It's this giant wave that's coming that I realized when I was in college, and I'm really proud to be part of this industry. So as far as feeling like I'd missed out on it, it just wasn't true at all. My generation, we did not invent this technology. We also didn't disrupt it when, all these startups started to form. But what we are here to do is to mature the technology so that eventually it stands with other mature technologies like CNC machining and injection molding and so on. So that if there's any students listening today, like that's a message that I really want to convey, is that this industry is, developing, and it's really going to be you guys as you graduate to, drive the expansion and bring it to the level that we see it progressing into. So that's kind of my story of, how I started at UMass and gained a interest in 3D printing just from tinkering with hobbyist machines, and eventually kind of transformed into exposure on the industrial side of things. Applied that learnings in a manufacturing company, but then circled back to the 3D printing industry, and this is where I am today. So we'll kick it back over to Jason, and we'll sum things up, and then we'll have time for a few questions.
Awesome. Dave and Ross, thank you for joining in and providing some insight today. So again, kind of back to the overall theme of today's webinar is, again, reinventing manufacturing today so students can build anything they imagine tomorrow. So as we kind of close out here, you will see on the bottom of your screen, there is a way for you to ask questions to us. We do have a few questions kind of rolling in as we've been presenting. I have a question kind of for Dave. Dave, I know you guys have been at this for a couple years. If you could go back, knowing what you know today, if you could go back and make different decisions, is there anything that's like you really wish you would have known when you started that you then found out years later about building this program?
Oh, sure. I mean, everyone always has things they would do differently. I think this might be a challenge everyone has. I don't know if there's necessarily a solution, but when I arrived, actually all of the printers were already purchased. So $3 million had been spent, and then we all of a sudden had to learn how to use all these printers all at once and try to get them going. And if there would have been a way to have the money sort of in the bank, but then buy maybe one at a time and learn about it and get it running and then buy another, I think that, first it would make us better buyers, because we would know kind of what things we like and don't like about printers and how to be more educated about the space, particularly since they're all like different, they're polymer and they're metal and they're different technologies and stuff. But also, I think you want to make sure they're getting fully utilized. So you don't want to be adding new capacity if your current capacity isn't totally used. So I think the other part was that if you buy them too early and they don't get used, they get obsolete because it's moving very fast. It's not so much that it's not usable, but it's not cutting edge anymore. So if we could have spent the money more slowly, that would have been great, I think.
Nice. We got another question that flowed in. What types of entry-level engineering positions are seeking skills in 3D printing? And I guess I can field this one with some of the positions that I've seen when we go to visit companies and some of the younger engineers that I meet. One of the biggest industries that's booming right now with 3D printing is automation. Anything with robotic cells, things that assemble parts together and do it in the scale of hundreds per minute. A lot of end effectors and robotic grippers. That's an area that engineers can be designing parts at an entry-level position. Really anything to do with fixtures. It's mechanical engineering jobs. Having these 3D printed skills really makes you much more marketable, because like I said, it's a skill that isn't widely available today, and where we're finding the students most equipped to apply these skills are the ones graduating from university, happening right now. Further points about like having these type of skill sets is it's also a marketable skill towards internships, because a lot of companies will purchase 3D printers and then utilize interns to say, hey, can you figure out this 3D printer for us and help us build processes around it? So there's certainly a lot of jobs that are highly applicable, not to senior engineers, but entry-level associate levels as well. We have another question for Dave. Do you tour groups, i.e. high school students, through the AdFab lab? If so, how do you highlight the equipment and solutions that bring AM to industry? For instance, when you just do show and tell, or have you found an easy way to get the students hands-on with the equipment?
Oh, that's a great question. We do a lot of tours, both UMass groups, we do high school groups. I think we've done even younger groups too. That was before COVID, so I don't know what our tours are going to look like going forward. But yeah, we're certainly accessible to all kinds of students to learn about additive. It is mostly showing parts and looking at printers in action. Usually they're printing live. I think that's not as good as getting them in there to actually do it themselves. But it is a lot of technologies that kids haven't seen before, and a lot of them leave pretty amazed, which is great. When we do our workshops for industry, I try to keep the group size like 3, and we actually do stuff, so you actually get to do a lot of the things. So I don't have a good solution for getting lots of students hands-on experience quickly, but there are ways we can do it for smaller groups.
Thanks, Dave. We have time for one more question. I'm on field this one from Evan. What is your view of metal AM in future in terms of application other than aerospace or motorsport? So you might read like headlines that metal additive manufacturing is, kind of being dominated in the aerospace industry. And it's not entirely true of the full scope of what metal 3D printing has potential to do. And really it comes down to a single value prop of making the part at the time and place that you need it. Me personally, I don't have the skills to hop on a lathe and, make a custom pin, but a 3D printer, I have perfectly capability to design it, send it to a printer, and have that part, a few days later at the time and place I need it. So that is a problem that we see with any type of manufacturing industry that has built up a supply chain. And as time has gone on, those supply chains have expanded and, globalization and have gone all over the place. By bringing this technology back in-house and the skill set to take advantage of it, extraordinary benefits with lead times and cost savings.
Awesome. Well, I know we're coming up on the hour. Everybody, thank you for joining us. In closing, I do want to thank Dave and Ross for joining us today and sharing a lot of their experience as they've gone through this. One thing I will mention that if you've been on your website, you might have seen before, but for everybody else, is a lot of what we talked about today about, again, how our customers have adopted this technology and then some of the success they're seeing on the back end. Please go spend some time, take a look at our new additive trends report that was just released last week. You can find that on our website. If you go at markforge.com, there's a banner on the top, or go to markforge.com /additive manufacturing movements, and you will go there. Again, within that, you could find a lot about our manufacturing clientele. You can also see really cool case studies from the educational industry specifically. Something like what you see in the bottom left-hand corner from North Carolina School of Science. It's a 2-year high school program, and they're doing some really, really cool things with their composite technologies. So again, I know there's some questions that we were not able to get to today. We will follow up offline with that, but if you have any additional questions for the Mark Forge team or Dave for joining us, please let us know and we can connect everybody. Thank you.
Thanks, everyone.